Okay, so the next thing we want to look at is vector representation of complex numbers. We looked at this a long time ago when we were doing partial fraction expansion, and it was a little bit artificial at the time, I understand. But it's actually pretty important right now. So let's look at an example. So f of s is equal to s plus 3, which we can write as s minus 3, right? So let's draw this. So we have -1, -2, -3. And then we have J1, J2, J3. All right, so f of s of -3, right? That is, I got a 0 here at -3. And what we want to look at is we want to evaluate f at the location -1 plus 2j. All right, we could choose any location on the complex plane. Obviously, as we go forward, we're going to pick particular values, but this in this particular case, so -1, 1 plus 2j. All right, so we can just plug all that in, right? So this is plugging this into f of s. I've got -1 plus 2j plus 3 is simply equal to 2 plus j2, which if you look, right, that is simply this vector, right? I am going over 2. So I'm going over 2 and I'm going up 2, right? 2 plus 2j, right? And so this vector, right? So this is 2 plus 2j, right? And this, we can write it in terms of we can also do it in, right? So this is in rectangular coordinates. We can also do it in polar coordinates, right? In terms of magnitude and phase, right? So the magnitude of f of -1 plus 2j, right, is simply equal to what? Square root of 2 squared plus 2 squared, right? So this is 2 square root of 2, which is the length of this vector, right? So 2 square root of 2. And then we have an angle. So f of -1 plus j2, right? We can probably see what the angle is right here, right? So this angle here, right, looks like it's 45, and in fact, right, we're going over 2 and up 2, so inverse tangent of 2 over 2 is equal to 45 degrees, right? So we can write, right, f of -1 plus j2 is equal to 2 plus j2, but it's also equal to 2 square root of 2 with an angle of 45 degrees. So in general, right, so here's I simply have right, in general, I'm going to have more than one 0, right? So if we're looking at a transfer function, right, we've got f of s. There might be some type of gain here, and then I have s plus z1, s plus z to the m. So I have m zeros, And then I have s plus p1 all the way to s plus p to the n. So I may have n poles. Well, right, so I can write f of s is equal to its magnitude and its angle, right? Same thing. So the magnitude of f of s is just equal to the magnitude of the components, right? So we have the magnitude of A times the magnitude of S plus Z1 times the magnitude of S plus Z sub M. And we're going to divide by S plus P1 times S plus P to the N, right? So we just multiply the magnitudes in the numerator and divide by the magnitudes in the denominator. And then likewise, the angles, right? The angles, what the angles in the numerator add and the angles in the denominator subtract, right? So we have the angle of A. So it doesn't mean an angle of A, it's just whatever that number is, it has an angle. Angle of S plus Z1 plus all the way up to angle of S plus Z sub M. And then we're going, because in the denominator, we subtract the angles in the angles of the poles. I got S plus P1 minus all the way down to angle of S plus P sub N. Okay, so what we're going to do then is we'll finish today out with a slightly more bigger example here. So f of s is equal to 10 times s plus 3 over s times s plus 2. So what we'll do, let's go ahead and sketch this. So we got -1, -2, -3, J1, J2. Okay, so let's go ahead and we have zeros, right? We have one open loop 0 at -3. We have two closed loop poles, one at -2 and one at 0. So what we're going to do again is we're going to evaluate f at -1 plus 2j. Now, so let's see, -1 plus 2j. Now, if you notice here, right, we're going to have 3 vectors, right? We have the vector from -3 to here. We have the vector from -2 to here. And the vector from, we don't have that vector. So hopefully, you guys are all doing this electronically and can erase that. We have the vector from the origin, the pole of the origin to there as well. Okay, that wasn't very good either. So let's try that one more time. Yeah, that's a little better. Okay, so we have 3 vectors. And, right, so it's not too hard to, right? So we have this vector here goes from -3 to 1 and then back up to 2. So it's what, 2 plus 2j, or we can write the magnitude of that is 2 times the square root of 2. And the angle, again, we're going over 2 and up 2. So the angle here has to be 45 degrees. This one, right, we're going over 1 and up 2. So what? Square root of 1 squared plus 2 squared. So this is going to be square root of 5. And the angle, we're going up 2, we're going over 1. So if you take the inverse tangent of that, we end up with an angle of 63 degrees. And then finally, we're going over from this pole, we're going over 1 and up 2. So the length of that is going to be the same as this one over here. So this has got to be square root of 5 with an angle, square root of 5. And then the angle is the only difference here, right? Instead of, remember the angle is always going to be from the, we're always going to measure angle from the positive real axis, right? So this is 45, that's 63. This angle here has got to be 180 degrees minus, what, this was 63, right? So 180 minus 63 degrees, so this is 117 degrees. All right, so this is 117 degrees. So we can, right, we can break this down in terms of magnitudes and angles, right? So the magnitude of f of minus 1 plus 2j is equal to, well, we have the magnitude of 10, right? So we have 10 times the magnitude of s plus 3, which is over here, right? So we have 2 square root of 2. And then that's in the numerator, right? And then in the denominator, we have the lengths from both of the poles here, right? So we have, from the origin, we have square root of 5, and from minus 2, we have square root of 5. So we have square root of 5 times square root of 5. We multiply that all together. We end up with 5.65. All right. So, and then finally, we have our angles. So angle of F angle, let's erase that. Angle of F of minus 1 plus 2j. We're going to add up the angles of everything in the numerator and everything in the denominator. And so, and subtract everything in the denominator. So in the numerator, we have the angle of 10, which is just a real positive real number. So the angle there is going to be 0. And then we have the angle for minus 3, which is over here. So that's 45 degrees. Oops. So we've got 45 degrees. And then we have the two angles in the denominator, right? We have the one from the origin, which is 117, and then the one from minus 2, which is 63. So we have 117 degrees plus 63 degrees, which turns out to be 180. So this is minus 135 degrees. Okay, so this is, right, so this is a magnitude of 5.65 with an angle of minus 135 degrees. Okay, so what we will explain next class period is why this is so critical. Because what this is going to lead to the two fundamental properties, basically the magnitude criterion and angle criterion. And we're going to use those a lot for design and for sketching the real locus. All right, well, you have a great Tuesday, and we'll talk to you later.